And we are live. Hello, everybody. Welcome to this meetup on GitOps and developer self-service in Fintech. I'm glad to have you all here. I'm here today with Steve. Is Steve or Steven? It's Steve, right?
Steve, yeah, unless you're my mother.
Okay, no, I'm not your mother, so I'll stick with Steve. So I'm here today with Steve, and we're going to dive into this super interesting topic in a second. But we'll give this a few more minutes to allow people to join. If you already joined and don't know what to do, except for listen to me, then feel free to say hi in the chat. Maybe include the location where you currently are. Always a nice touch. Make sure to select to all attendees before sharing your message, because otherwise only Steve and I can read what you wrote. Yeah, let's see who's first. It's always interesting to see who's first. No one dares to. Okay. Chicago, nice. Quebec City, Canada, welcome. Toronto, nice. Used to live in Canada for quite a while. London, UK, Nigeria. Okay, so we have a Stockholm. Cool. We have a very international crowd. Denmark, Munich. Welcome, everybody. Maybe a few housekeeping rules. So this meeting is being recorded. As you can see, we'll share the recording with you tomorrow in an email together with some useful links. If you have questions during Steve's presentation and while he's talking through some of his challenges and what GitOps and developer self-service are and can be in Fintech, feel free to either use the chat to ask questions, or there's also a Q&A function you can use. I'll monitor both. If you want to make sure your question sticks and doesn't get lost, use the Q&A. But I'm monitoring both, so don't worry. I'll make sure that your question reaches Steve either during the presentation or in the end. I think I'll just give this one more minute. You're not really sitting where you appear to sit, right, Steve?
No, this was me last week. So I took one of my first breaks during the pandemic because of the joys of being able to work remote. So this is the Peak District. So I went there for a week. Yeah, just as a break, hit the reset button, did a kind of digital detox. So
nice.
No very limited phone access, no TV, no laptop, no nothing, and just kind of went off the grid for a week. It was lovely.
Sounds good and looks great. Fall already there. Some nice colors. Cool. So I'd say let's get started. I expect a few people will join a bit later, but let's not wait for longer. So maybe to repeat the housekeeping rules. So this meeting is being recorded. We'll share the recording with you tomorrow in an email with some useful links. If you have questions during the presentation, feel free to either use the chat and make sure to select to everyone before doing that, or use the Q&A function. I'll monitor both. Maybe to introduce myself briefly, I'm Christoph. I'm co-founder of Humanitech. We are helping companies to build their own internal developer platforms. But this meetup isn't about that. It's about you and your journey, Steve. So I'm happy to hand over to you, and would be great if you introduce yourself.
Sure, no problem. So my name is Steve Wade. I'm an independent kind of consultant and trainer in a number of different fields. The one that we're going to kind of talk about today is building platforms, and mainly around kind of Kubernetes and GitOps as a pattern. Down there are my kind of social links, website, Twitter, and also if you want to reach out to me on email, feel free to do so. So I want to start with this quote by the man himself in the Kubernetes community, Kelsey Hightower, which says, he says, once you found success, your next goal should be to help others do the same. And that kind of really resonates with me, specifically in the roles that I do with consulting. And, you know, I've been lucky enough to work in a number of different fields, large and small companies, and seen a lot of the problems that exist, and have tried to create patterns that will allow companies to not have to grind the gears the same way that the previous companies that I've been on site had to do. So I kind of rephrase this ever so slightly to, once you found a pattern that works, your next goal should be helping others to do the same. What you'll also notice is that I didn't put the number of retweets and likes on here because Kelsey does me about 1 to 1,000. So just a little bit of an agenda here. I want to talk about the common problems. So in a lot of companies that I've been consulting in, specifically in the fintech field, but this is not just around the fintech field, this is in general. The problems that I see when I go and when I land on site, a little history lesson and the journey thus far, and then I really kind of want to talk about the challenges and how you can get started building this. So if you are or aren't in fintech, you're probably going to come up against some of these problems that I'm about to go through, and I'm going to walk you through a kind of fake implementation of how I've done this in the past to provide developers with a self-service platform. So the problems. So the one that I see the most often is this kind of ticket-driven development process, whereby the platform engineers, and I'm specifically talking about platform engineers here, have a long list of their own requirements, and then they also have another list of the developers' requirements. And like any good engineer, you know where the developers' requirements end up at the bottom of the list, right? Because my requirements for the platform are way more important than developers' requirements. So this list just gets bigger and bigger and bigger and bigger. And then what happens is the developers just get more and more and more frustrated, right? No one wins in this model, right? But it's a model that I've seen, and a problem that I've seen absolutely everywhere is that just tickets keep on coming, and the backlog is like hundreds and hundreds and hundreds of tickets. And there's no way of being able to consolidate those down and put them into necessary buckets, because that alone would take another sprint. So we just add to the bottom of the list again, right? And the problem just keeps getting exacerbated. And then this awful word called ClickOps, which is kind of the reverse method of GitOps, where you drive everything with Git, where instead of doing that, people decide to drive it by button clicks. So they go into the console and they randomly start clicking, and they've added a load balancer, then they've added a couple of EC2 instances. And then before you know it, production looks like an apple, and then development and staging looks like some kind of banana. And the developers get things working in development, but then when the time comes for them to deploy it to production, production looks nothing like development. So nothing really works. So because of that, this happens, right? And every single release from every single product team seems to take ages. And in some instances, in some companies that I've consulted in, this is okay. There's no problem. You know, it just takes 4 or 5 weeks to deploy, a one-line code change in some examples that I've been in the past. That's just understood, and it's accepted. But in the world that we're living in today, specifically the digital world and the online world, like being able to iterate fast is what gets you ahead of your competitors. And you don't want this slow release cycle like this snail here. You really want some kind of rocket ship where you can get out the way and allow developers to be able to iterate and get new features and functionality in front of their customer base. Then kind of coming back to this ClickOps mentality and this slow release cycle, you have the problem with every change that you make being risky, whether that be a new feature that you're about to deliver, or whether that be a change that you're making to the underlying platform. And because things have been semi-ClickOps and not all of it's been ClickOps, and then someone span up and said, how about we start using Ansible? And then another team's come up and said, oh, let's just give Terraform a go. Oh, you can do Ansible with Terraform. Okay, well, let's try that as well. We've got all these different ways of doing stuff. So all of the changes become really risky because, unfortunately, when you're in this microservices world, your application does have to talk to other apps. You don't just live on an island over there and you can do everything you want to do and don't have to worry about anybody else. There is this communication. And then because in the old days, years ago, people were deploying these monolithic applications, so they didn't really worry about any kind of integration test. They just tested the whole damn app in one go. So when I deploy my microservice over here, I don't really know if it's going to work with v2 of the other microservice that's my dependent. So as well as that, this happens. So production changes become even more riskier than the ones that you're doing in development and staging. And this was me a couple of years ago, actually on site. I jest, that isn't actually me. doing some production changes and actually witnessing people doing production changes. People in war rooms, they've opened out a 50-seater, round table, conference table, and getting people sitting in there trying to understand and break down how a change to the product service seems to have crippled the whole entire platform. And all of this just breeds negativity, no matter where you are in the hierarchy, right? As a CTO, you're thinking, what on earth are these lot doing? And then as a developer, you're thinking, this is just ridiculous. Like, all I want to do is ship features to my customers. And now I'm sat in a war room with a bunch of people that I don't even know, trying to work out what the problem is. And it just breeds this negativity and this slow way of working. And that's not really where we want to be. Then this happens. So this is me as a consultant, and I've sat and I've been to all those different war rooms and I've seen all these things. And then I get called up and they say, Steve, well, we brought you on site. What the hell are you doing? Like, you're supposed to be fixing all these problems, or change this to some kind of tech lead. It doesn't necessarily have to be a consultant. This is a tech lead having to explain or trying to explain why his microservice brought down the whole of production, not understanding how all of production works, only understanding how his microservice works. Right. And now a blame culture is starting to come, where it's really, we just blame the next person or the other product team, or the lowest common denominator is always just blame the platform, right? Every good engine, every good developer just blames the platform. It's the platform's fault. We deployed it, I was running it locally and it worked fine. It must be the platform. So Vince Lombardi always said, confidence is contagious and so is the lack of it. So if you're breeding a lack of confidence, that makes hiring somewhat difficult. People are leaving. There's a natural attrition there because people don't want to work in this kind of environment. And there's always this butting of heads between the people that are maintaining the platform and the people that are using it, right? And the more these heads butt, the worse the problem gets. What we want is this harmony, where developers and platform engineers all work on the same platform together. And the platform engineers allow the developers to be able to succeed, right? And we're going to come on to that a little bit later, what I mean by that. What we don't want is this, right? This is what I see in every single company that I go into when I first join on site, is this massive tug of war where they just all blame each other. So they're kind of the common problems that we've probably all experienced in the past, but how do we build what I would deem the perfect platform? And to me, it's kind of easy-ish if you follow these set of steps. So the first step is always some kind of strong mission statement. And what you do with this mission statement is you just bombard it with buzzwords so that all of senior management seems to think that you know what you're talking about. And there's some kind of North Star of where you want to head to. And all you do is essentially fill it with words around the problems that you've seen, right? And for me, this is the one that I kind of always use, which is easily extensible, because you're not just going to be deploying a platform V1. There's going to be multiple iterations of this thing. You're going to be adding different components here, there, and everywhere. Config driven. So basically reverse ClickOps, the complete opposite. Ephemeral platform. So I've been on site with nodes that have been running for thousands of days, and people are actually scared of removing them from the auto scaling group because they're unsure about what kind of files and keys are on those nodes. So they just leave them there. And they're just that kind of snowflake that sits in the corner. It's the equivalent of being underneath someone's desk. They just leave it in Amazon and don't touch it. And then we come on to the ones that are really important. So clear ownership and reliable and consistent. If we get the ownership and the boundaries correct, product team A can work on the platform and not have to worry about clashing with product team B, right? And they can iterate at their own speed in a consistent fashion, but allowing them to be able to iterate. And then reliable and consistent. Well, if the platform is not consistent, we've got the apples and bananas problem. What we want is every single platform being the same shape apple, the same color, but maybe just a little bit bigger or a little bit smaller. But we deploy to dev the same way that we deploy to production. We add infrastructure to dev the same way that we add infrastructure to production. Nothing is different. Consistency is key. right? Once we have consistency, everything becomes a hell of a lot easier. So let's take the first bit, the easily extendable and config driven bit. How do we actually, come and deploy and build this part of the platform? So the first step in order to be able to do this is we really need to build some kind of base platform. And at the most simplistic way, we're going to use AWS in this scenario. We're going to use Kubernetes as the natural abstraction layer above the infrastructure. So we have a common playground where everyone can deploy their workloads and their applications. And then all we're going to do is we're just going to whack the workloads on top. So that's the starting point, right? That's the kind of 30,000-foot view. But how do we actually go about building this? So in the past, what I've done is had a dedicated repository for all Terraform modules. So we're going to use Terraform as the tooling to be able to allow us to create infrastructure. There are many other tools that you can use. Terraform is just the one that has got the most adoption and has the most providers and allows us to be able to be flexible on what we are trying to do with said infrastructure. We're going to have a single cohesive repository with all of the Terraform modules. Why do we want to do that? Because we want to build consistency, right? I want to lint that the same way that I want to lint my new module the same way that I lint all of my other modules. I also want to share different modules. I don't want every team creating an S3 module. I'll create one S3 module and you can all consume it, right? Not every engineer is Amazon certified and knows how to create a secure S3 bucket. So we'll provide them with a module that does all that for them with a couple of parameters, and they can configure it and use it. And we'll come onto that in a second, what that looks like. And then a number of dedicated Terraform routes. So what do I mean by routes? I mean repositories that are executed to stand up certain parts of the infrastructure. So if you think of a repository called tfenv k8, that's probably going to stand up the Kubernetes cluster or the EKS cluster. Then we have tfenv data product team. Well, that's the database for the product team or the S3 bucket or any kind of data. By having these different repositories that have different owners, we're splitting the big platform into many smaller parts that have their owners and have their own ways of working. So here is an example of a Terraform modules repository. You can see there that we have a pre-commit, we have some Git leaks so that we don't, someone doesn't accidentally commit their database credentials or some kind of Amazon secret key or an access key. I'm not going to tell you how many times I've seen that if I go back through companies' Git history of that. So anything we can do to stop that, is good in my book. And then what you'll notice here, is we now have our modules, and the ones that I really want to call out are the ones application dash. So application dash IAM role, well, we'll create you an IAM role. We'll be hooking it into the Kubernetes cluster. So we've got a fairly good idea of what your IAM role is going to look like. And then application S3 is going to be the module that you consume to create your S3 bucket. Well, there's no point in you doing this all individually. How do we consume this? So here's an example. We've got a Terraform block at the top there. And then at the bottom, we are executing our Kubernetes module at a specific hash, and we're passing in the information that we require. So that's kind of the instantiation or the execution of said modules. Then if we're an application team, they may want to create an application an S3 bucket. So they can do that by executing the application S3 module, passing in the key pieces of information. So the stack that they're deploying in, the stack probably most likely being the product, the application being the microservice that's going to use that S3 bucket, and then some kind of metadata about where it is being created. Then the same again for an IAM role and with an application name. And then we're attaching the read-only policy for the S3 bucket to that IAM role. So that IAM role is going to get read-only to the S3 bucket. This was the first iteration. There were many iterations we actually worked with product teams to shrink this interface down to the bare minimum that they needed. There's still a little bit too much Terraform here for people that don't understand Terraform. So yeah, that was an iterative cycle, but I kind of wanted to show you the first pass. So now we've got these modules, and that, you know, they've all been kind of signed off in inverted commas as secure, and they've all got nice linting. Well done, Stephen. Congratulations, you've built this with your teams. I need to make this developer friendly, right? And this is the one that wins, right? If I can make it developer friendly, I'm going to make my life a hell of a lot easier. Developers, all they do is they sit in their IDE and they like to review pull requests. Some of them do, some of them don't, but they all know how pull requests work. So how do we make infrastructure changes? Well, we do it via pull request. So we use a tool called Atlantis, and Atlantis's job is to take the Terraform that's as part of the pull request, execute a plan, so a Terraform plan, print out the changes that it is going to make, and then you type in as a comment, Atlantis apply. Atlantis applies your Terraform changes and then merges your pull requests, right? The same way that you're developing code for your pull requests for your applications, it's very similar now for how we make infrastructure changes. So that GitOps term and driving everything from GitOps, this is just the very start of that. This is the infrastructure piece. Then you can see here that you've added Atlantis apply, it's made the changes, and finally you go to merge the PR and close the branch. So that bit's great. Now we have to keep this bit right. So everyone knows in fintech that compliance and audit are like people's favorite buzzwords, that's all they talk about. And we have to remain compliant, and we could have an audit at any time. And how do we make sure that the product teams aren't doing anything, silly, which is changing the compliance posture? So I've leveraged a tool called Regular by the company Fugue. And what this essentially does is uses the concept of Rego policies. So if you're familiar with Kubernetes, you would have heard of Open Policy Agent or Gatekeeper, that's used to kind of run compliance checks against Kubernetes YAML. But here we're doing it against Terraform output. They support a number of different clouds, as you can see there. So how did we hook this in? Well, in the pipeline, after we do a plan, we save the Terraform plan as JSON, and then we clone a custom IAM policies repository, which essentially contains all of the compliance posture that we want for what a good S3 bucket looks like, what making sure that CloudWatch is turned on, et cetera, et cetera. There was loads of them. We run the policies against the JSON plan, and then we either pass or fail. If you fail, we're not even going to let you execute, so you can't even make those changes. If you pass, then you're the lucky ones that get to run Atlantis apply, and you get to apply those changes. Fugue also has a UI that you can hook in that essentially in the background runs what's called a baseline scan. So what we had in the background is Fugue configured to be running periodic scans against our environments. So this is only good if you're actually making a change. But what happens if you haven't made a change to an account for like 3 or 4 days or 3 or 4 months? Fugue has this scanner in the background that scans and checks against all of the known kind of compliance families. Think HIPAA, think GDPR, think ISO, et cetera, and can provide you a report about how secure, in inverted commas, and compliant your estate is at an account level or at an overall organizational level. So we've kind of got this compliance posture piece. We've got a way for them to be able to add Terraform. Now comes the clear ownership. If we can get the clear ownership right, the platform engineers are going to get out of the way of product teams. And how do we do this? Well, we're going to use this buzzword that is at the front of my first slide, which is GitOps. So people have heard about GitOps, and there's multiple different theories of what it means and how you can implement it. So I'm going to talk about how I see it. So I saw it when I was a platform engineer as this like awesome new thing where I don't have to push all of these changes into my cluster. I can get something to pull them, and I can use Git as the source of truth, and it all looks great. And then over there, you've got the developer going, what on earth are you talking about? And by the way, why haven't you done my ticket yet? So we want to turn this into a place where all three of these people are smiling, right? And everyone's getting on with their work. So before, if you're familiar with Kubernetes, there's many different ways that you can deploy your application. There's some kubectl commands there. There's some Helm commands there. Essentially, all of these kind of go in the bin, and they get replaced by Git merge. Hence the term GitOps, right? Git operations using Git. So we've done pull requests for infrastructure. Now we're going to be doing pull requests for workloads. So this is kind of conceptually how the GitOps operator or Flux works. Everything in that dashed box there is an EKS cluster or a Kubernetes cluster. So Flux is an agent that runs inside of your Kubernetes cluster and interacts with the Kubernetes API. Its job is to sync changes into the cluster. Oh, sorry. The reason why I like this model is because if you go into a client site and you tell them that you want to implement GitOps, and by the way, you know, all those pipelines that you wrote, you're going to have to rework all of them. That's not going to go down very well. If we say that we're going to embed GitOps into your workflow, that sounds a hell of a lot better and you get a lot better buy-in. So all we're going to do is we're going to sync workloads in via Git. So that's kind of the middle arrow coming out of the Flux CD rectangle there. And as well as that, developers can push new image tags, and Flux will poll the registry for new image tags. So kind of, you don't have to be a rocket scientist to work out the push image tags kind of is the CD part, or the continuous delivery part of how we're going to ship new images to new environments. And the Git commit is more around how do we onboard a new microservice for the first time. So we've got this mechanism now of being able to sync changes bidirectionally from the registry or from the repository. But most people are used to using Helm charts in the companies that I've worked with previously and work with now. So there is another component that kind of comes along in the Flux family called the Helm Operator. And its job is to take what's called Helm releases, and they are kind of resources that we'll come onto in a second. Flux syncs them into the cluster, and then the Helm operator interacts with the Kubernetes cluster and does your Helm upgrade or your Helm delete or your Helm rollback. So what does a Helm release look like? So here's an example. You can see it's really made up of two blocks. The chart block at the bottom, which specifies the chart and the location of that chart, and then finally the values that sit underneath it. So the values are the kind of overrides from the default chart that you want to deploy. Then you can add some annotations. These annotations here are what tell Flux to go and look for new containers. So this is saying, Flux, I want you to go and look for new image tags for Cert Manager that start 13.0. So if Cert Manager creates 13.0.1, Flux will go and get that. It will deploy that into the cluster, and then it will write it back to Git for you to tell you that it's done it. You can do the same with sealed secrets, same kind of method and methodology. You've just got a controller that sits inside that understands a custom resource. This kind of controller method, whereby you're syncing something into the cluster and then there's this kind of logic piece that knows how to deal with that, is very, very powerful. So we were using this at a range of different companies for a range of different things. So think Kafka topics. We had a repository for Kafka topics, and then we had a Kafka topic operator or a controller that sat inside of the cluster and interacted with Kafka and created topics or modified them or deleted them. So we're using Git as the source of truth, syncing stuff into the cluster, and then we have these kind of logical controllers that are really doing the heavy lifting. That's where the kind of complexity and logic comes. So the first repository that we're going to create is K8's releases platform. Again, doesn't really take a rocket scientist to work out what kind of releases sit in this repository. These are platform engineering workloads. So think logging, think monitoring, think like Prometheus, Grafana, Alert Manager, Thanos, all of the RBAC that's required, or the role-based access control that's required, all of the things that as a developer, you probably don't really care about, but you do if you actually want to be able to use the thing, or you want to be able to view logs. So as part of that, we also needed other repositories, right? And these repositories are around product teams. So each product team had its own K8 releases repository. And now what you can see is a new product team comes on board. We have a pattern for when that happens. What do? We create a new repository. We've scaffolded this all out. So it's a template in GitHub. You create a new repository. It creates you this directory structure. All of the CI is already there. You don't have to worry about it. It's just going to happen. And you focus on actually being able to create your Helm releases, which is the thing that you need to be focused on. You understand how your application works. You understand the values that need to go into that, the environment variables, the config files, et cetera, et cetera. I'm removing all of your other problems from you. So let's take a closer look at what this actually looks like. So let's take an app X Helm release. It doesn't really matter what we're deploying. This is the non-environment specific version. So at the bottom there, you'll see that we're in customize base product team app.x.yaml. So this contains everything that is not environment specific. So this is not going to contain, how to go and find your secrets potentially. This is not going to create or provide any of your ingress rules. So applicationx.example.com, none of that. This is boilerplate. So the most amount of stuff to dry up this repository as much as we can, because when we get to the environment specific config, we want the bare minimum for that environment. Couple of things you'll notice here. The chart version has not been specified, and neither has the image tag. The reason why those are very important when we start to come onto environments. They're going to define and derive what containers go to what environment. Now here's the dev one. So what you'll notice is in the annotation, we've now added this glob, and this glob is going to say, okay, well, anytime you see a new image tag that starts dev-star, I want you to go and deploy it for me. So think continuous delivery. Now, as a developer, all I care about is uploading new images to the repository. All the rest of the deployment mechanism is going to be handled by Flux. The chart version here is in the environment specific config, because if we're running different versions of Kubernetes, different configurations happen, right? APIs get deprecated. So that chart version is tightly bound to the version of Kubernetes that we're deploying to some degree. So when we were running Kubernetes 1.14 as an example, the chart was 1.x. When we moved to 1.16, we moved it to 2.x. And that meant we knew that if a whole environment had been cut over to the latest, or the 1.16 release, all of the Helm releases needed to be 2.x. What you're probably seeing here is there's some kind of pattern of how we can onboard new microservices, right? So what we do is we just copy and paste this methodology for all of the other workloads. So start with your non-environment specific configuration and then work out what your environment specific configuration is. And that dev dash is very important. So when we deploy to staging, it's studge dash, so STG. Then when we go to production, it's PRD dash. What that allows us to be able to do is create another environment over on the right-hand side for an integration environment. And we can, if we want to, we can sync all of the production cluster, all of the production images if we want to. And we have an exact replica of what production looks like minus the data. So moving swiftly on to continuous integration, because if we didn't have continuous integration, we would just be deploying horrific messes all the time. So this is the developer workflow. So again, the binary, or the code, sorry, was stored in GitHub. And that tool that they use is completely up to them. Again, we are hooking GitOps into their pipeline. We are not telling them how to build pipelines. That's their, that's their comfort zone. So in this instance, we're just going to take concourse. They perform a Docker build. They tag it with the git with dev dash and the commit char, the long one. They push this up to the registry. Over inside Kubernetes, we've got a Flux instance that's sitting there looking at our new registry. It patches the Helm release. So it does all this inside of the Flux container. It does a kubectl apply with your patched Helm release. So we've gone from dev-123 to dev-2345. And then it commits the changes back to Git. So the last piece of that puzzle is the powerful one, because now it's in Git. I've got a historical log of all the changes that have ever been made to my cluster. So when Mr. Auditor comes knocking, I can tell him all of the changes that were ever made since the cluster came up, right? There's a number of different repositories, granted, but I can just walk him through Git commits. So do any of you remember when an auditor had to come in, you had to start creating this spreadsheet and filling it out, and you had to go to a number of different files and go and get all the information? All of that goes away. We're using Git commits as the source of truth. So what I've did in one of the companies is we put a UI on top. So when the auditor came, we showed them the UI. We went to auditor.example.com, and behind the scenes, it's interacting with GitHub. It's doing API calls, and it's pulling back the information that they care about, because they didn't want to see us go through a load of Git commits. If you keep auditors happy in Fintech, you're onto a winner, by the way. In Concourse, we're doing essentially we sit in a wait loop. So this wait loop says, has my new application been deployed? And because I know the image tag, I label my applications with that image tag. So app_version equals dev-1234. And I just sit there waiting. Once it's done, they run their tests, right? This is the thing that they really care about, the confidence of going to the next environment. That's their area of expertise. Then they retag the image with UAT and they push it, and we just go round the loop again. And this time they're doing UAT tests rather than development tests. And yeah, we just rinse and repeat. So pretty simple, right? Again, it's all about consistency. So consistent tagging taxonomy of your images, consistent labeling taxonomy of your Kubernetes workloads. Everything comes together nicely, means that you start to create these cookie cutter pipelines. So again, thinking about how do we onboard our next microservice? How easy can we make it? Right, okay, well done. You can deploy applications. Congratulations. Like you can deploy new workloads. But what about the Kubernetes changes? Because everyone knows that Kubernetes changes, every 10 minutes. So now we don't need a kind of on-premise or in our ownership CI solution. So just for simplicity's sake, I've just chosen Circle. And we can run a number of checks against our Kubernetes clusters, our manifests. So in K8's releases platform, in K8's releases product team. So deprecation checks. So again, using Rego and Open Policy Agent, this is checking to make sure you're not using deprecated APIs. Everyone knows Kubernetes loves to deprecate APIs. So getting ahead of that is great. We were running 118, but checking against 121. So we knew that we could upgrade to 121 and nothing was going to break. Telling developers that they have to go and change all their Helm charts because we're upgrading to a new version of Kubernetes, that never goes down well either. Going and telling Scrum Masters and product owners that they need to go and do tech debt. That's not tech debt. It's actually platform maintenance. You don't want to be doing that either. Kubeval is making sure that what you're deploying is valid Kubernetes YAML. Again, developers are not Kubernetes engineers. They shouldn't need to be Kubernetes engineers. Anything that we can do to make sure that they're not trying to deploy something silly is better. We want to catch it as part of the PR, not once it's in the cluster, because they're only going to be coming to one place. And then finally, HR Val is kind of a combination of the two of them. So if you remember, we are deploying Helm releases, and a Helm release is a chart plus some overrided configuration. So what you're actually deploying are kind of the internals of a Helm release. So what HR Val does is takes your Helm release, goes and gets the chart at the specific version, does what's called a Helm template, which essentially renders out the YAML with your values, and then runs kubeval and conf test against that, because that is the actual thing that you're deploying. So we've now done the CI part. We can make changes to applications. We can also make changes to Kubernetes. So how do we kind of make it reliable? So the way that we make it reliable is we need to bring all this together in a, what I would call a one command kind of Rise of the Phoenix style cluster configuration. So we know we're going to use Amazon, or we're going to use any cloud, and we're going to use Terraform to do this. We're going to put Kubernetes on top. And the first thing we need to deploy is K8's releases platform, because that's the kind of foundational workloads that we need in order to be able for everything else to come up. If that doesn't work, nothing else is going to work. So when we execute K8 releases platform, we need to provide it with some data, some configuration. So what branch, what path? So you'll notice here, this is probably for the dev environment. So we're going to be using customized dev, and we're going to sync back to a tag called dev. So what that does is it stands up the cluster, points at K8's releases platform at the customized dev directory, and then it starts to deploy other Flux instances. So we need a Flux for, in this example, K8's releases Metal. That deploys the Metal workloads. This could be any one of your product teams. K8's releases secrets. That's going to deploy all the secrets for the environment, right? It kind of keeps going, right? All of the different components that you need. And then they all sit under some directory / environment prefix. So if you keep the same environment prefix throughout all of your repositories, this whole kind of cluster stand-up becomes very trivial. And then when you want to create a brand new environment, you just agree the character prefix for that new environment. So if it's integration, it might be int. And you clone all of the different directories, you change dev to int for the bits and pieces that you need, and away you go, you've now got an int environment. And this kind of horizontally scales for the new product teams that you bring in. The way that we broke out and split out our repositories was very much around owners and approvers. So who owns these repositories and who can approve them? There was no reason why a developer couldn't commit a PR back to K8's releases platform, but it had to be approved by a platform engineer, and vice versa back to them. So if we wanted to say, why in development are you running 3 replicas? Can you not just go down to 2? We'd create a PR to 2. We'd explain them the reasons why we think they should go down to 2, and they can approve it or they can reject it. Again, it's a platform that everybody can use, completely open. So what were the challenges along the way? So one of the biggest challenges that you have is this kind of cluster creation and platform implementation takes time. So there was a lot of this, like, what on earth is that platform team doing over there? They've been spending months and months and we haven't really seen anything because they're putting all of these kind of building blocks into place. So one of the kind of things that I'd recommend is, if you're not doing it already, is do regular showcases as a platform engineering team. Even if you don't think you have a lot to talk about the direction that you're going in, talk about the decisions that you're making, talk about how you're going to make it easier for them as a development team. All of those things that developers do care about, they may not necessarily care about the technical pieces necessarily, but when you show them that you can add a new PR, and within 15 seconds it's reconciled in the cluster, and they've got an endpoint that they can hit with a certificate on it, it will blow their mind, right, compared to what they have to do currently. This one's pretty obvious, right? The technology is the easy bit. It's the people problems that are the difficult ones. It's agreeing and getting buy-in from the different product teams that this is the right direction of travel. And then when you tell people that you're going to remove their ability to run kubectl apply, people start to jump up and down and throw chairs. But again, it's this journey of the direction of travel of where we want to go to, and the fact that we're enabling self-service, right? And as soon as we start talking about self-service and we talk about how, as platform engineers, we're going to get out of your way and we're going to let you be able to iterate, these problems start to dissolve. And one of the other things that I'd highly recommend is doing regular feedback sessions with your product teams. So we always, at the end of every month, used to ask the same questions. What's the coolest thing about the platform? What's the worst thing about the platform? And if there's one thing you could change about the platform, what would it be? And those became our top level epics, essentially, that we had for the next month. And then what we're doing is we're working on stories that directly correlate to keeping our developers happy, right? And we're making this self-service even more self-service, and we're getting out their way, and we're kind of smoothing out those rough edges that they had previously. So there is a blessing and a curse when it comes to GitOps, and it's what I call GitOps, which is if for any reason the cloud provider that you're currently using to store all of your Git configuration has an error, you basically can't deploy anything within reason. So always have a break glass scenario where someone can run kubectl apply and deploy the YAML files or the resources that you need to the Kubernetes cluster. But that's a break glass scenario. That's not the standardized way, but always remember to have that. And there's a couple of main takeaways for me with regards to this implementation. So I asked a couple of the clients that I've been working with in the past 2 or 3 years to kind of pull back some numbers. So production deployments up 50%, mean time to recovery of a complete cluster outage, 20 minutes, and developers being 75% less focused on operations. That means that the developers are focused in the area that they need to be focused in, which is delivering value to our customers, bringing in more customers and keeping our customers happy, like the business's customers. And the mean time to recovery keeps like the CTO happy that you're not, that if there is a major outage that we can always come back from it. Faster deployments means faster iteration, which means that hopefully you can get ahead of your competitors or at least be chasing them. And I think the main takeaway from all of this is that the platform team's customers are actually the developers. So when I go into companies, I don't call myself a platform engineer. I call the team that I work with a developer experience engineer that has a focus on the platform. Because if we can make the developer's experience better, everybody wins in the long run. So how can you get started? There's a number of links here. Some of the tools that we've talked about at the top, some of the repositories down at the bottom. So deprecation is the repository that has all the deprecated checks. GitOps with Customize is just an example with some CI of how I build out these repositories for different clients. And then in terms of things that I've learned in the past, I blog quite a lot on Medium for better or for worse. In a lot more technical detail. I wanted to keep this relatively high level because I wasn't sure about the audience. But yeah, you can find out more there. Thank you very much for your time, and I open the floor up for questions.
Steve, thank you so much. I really enjoyed it. Maybe we can share the slides or at least these links in the follow-up email.
Sure.
Let's make sure that I especially liked the angle that you take on the developer experience, because that's something that's, I think, easy to forget while on it. And there's a lot of tooling for ops people out there, but in the end, it's the developers using it. So it should work for them. I think that's a very nice angle. We do have a couple of questions, and I think I give this another 5-10 minutes. We're running a bit out of time, but I think that's fine. So first question we got is, curious what your position is on where in an organization platform engineering should be. Should it align to the VP of engineering or VP of infrastructure or directly to the CTO? So how would you structure this?
So it's a good question, firstly. To start with, a core team, but a very, very small core team that is driven to design the way that the platform is going to be leveraged. And I'm talking about building out base platform, building out reconciliation loops. And then once you have a pattern that works, you've got to distribute that into product teams. And then that's when you pull platform engineers out into product teams to go and quote unquote onboard them. So that's what we did in the past. One of the platform engineers was pulled out, went and helped the product team get onboarded. As well as that, one of the development team came to the platform engineering team for a 2-week sprint. I don't really call us platform engineers. everyone to me is just an engineer with working on a different part of the machine and having a core competency in that part of the machine. So who should they report into? To me, is they should report into the CTO with the CTO's vision. And in terms of the direction of travel, they should to some degree be allowed to facilitate how the platform is used with the skills and expertise that they have. If there is an infrastructure department, this whole concept of infrastructure department to me is kind of an old school way of thinking to some degree of companies that are huge definitely do have infrastructure departments. But to me, it's all about consistency. So we built these platforms that I'm talking about. I've probably built maybe 50 of them in different companies, dependent upon a range of different scales. And I always come back to this point about the need for an enablement team. So if we're going to go on this journey, then I want an enablement team. And that enablement team is made up of different areas of the business. And that goes all the way from HR and the CTO, all the way down to some of the product leads. And I work with an enablement team. I'm not necessarily overly bothered about working directly or one-to-one with an infrastructure team or with a networking team or with a security team, because when we're building out this platform, my time will be so consumed by telling all the other teams what we're trying to build that we'll never be able to build anything.
Yep.
Whereas this enablement team came together and is really the interface outbound to all of the other teams. And then we used to have regular meetings with those teams. So at the scale that I've worked at currently, I never worked at a scale where I was working with the top level infrastructure engineering department. But what we were doing is we were kind of spinning up, in inverted commas, a venture or a way of working. And then we played that back to the wider community. And by the wider community, I mean the wider infrastructure engineering team. And then there was a pattern that worked for this product team. So one of the ones that I'm thinking about specifically is with a telco. So we worked on a telco project and we built this out. And then this kind of pattern and paradigm was used for other kind of ventures or other areas of the company as a whole.
That I think that makes a lot of sense. Also, I'm pretty sure I'm pronouncing the name wrong. Schuyler Bishop, who asked the question, also says this makes a lot of sense. And referring back to team topologies, I think great reference. I think reading the book Team Topologies is a good starting point to understand dynamics and what a platform team should be and what it should do. I think it's a platform only works if everybody is enjoying working with it. That's the one thing that you've got to take away. If that's not the case, then it's failed. Absolutely. Another question we got is how to deal with custom Helm charts being pushed to self-hosted chart repo like Chart Museum, and then use Flux CD.
Yeah, so you can. So I'm not really 100% sure that I understand the question there. I'm going to kind of I'll go with what I think you're trying to say, and then please post in the Q&A if I'm talking completely wrong. So you're talking about how do you manage custom Helm charts?
I guess that's the question, yes.
Yeah, so for us, we had a K8's Helm charts repository. That repository contained all of our custom charts. All of the linting that I've showed was also done there, deprecation checks, cube val checks, and we uploaded it to a registry, and that registry could, yes, be Chart Museum. We actually decided, I'm just using Amazon as an example here, to host the registry on an S3 bucket with CloudFront in front and basically turn it into a website, essentially. On merge to main or master, we would do the necessary packaging of those Helm charts with the correct images, versions, and upload those to the S3 bucket using S3 copy. And then we would leverage that inside our Kubernetes deployments. You could have a public Helm registry, that's completely public to the internet, or you could have some kind of IP whitelisting. I've done both. But essentially having a quote unquote publicly accessible URL that is either public via completely public or IP whitelisting will allow you to be able to consume those as Helm releases, as long as the Helm operator has the ability to go and get and talk to the Helm registry, everything will work. So for us, it was elastic IP addresses. Elastic IP addresses to a whitelisted endpoint.
Yeah, I think that's a great approach to solve the problem and make these charts available to everybody.
Yeah.
Another interesting question that I also found interesting: have you ever gone through a financial audit, like COBIT, NIST, SOX, etc., and validated auditors accept a Git commit log?
Yes. Yeah, we have, but it was a painful exercise, to be honest with you.
I can imagine.
Yeah. We always used to come back to the question. So there was a number of questions that I always asked. The obvious one: how long does it take for you to do a one-line code change to production? Then when you're running in fintech, it's how quickly can you get an auditor spreadsheet the thing that they need? And for us, it was, yes, the Git commits are difficult for them to be able to understand, but how can we provide them with a mechanism that uses Git as the source of truth? So that's where I was talking about the UI. So rather than this spreadsheet that we provided them with a UI that we'd bring them in on site, and we'd go through and use the UI, and then we'd export it as some kind of CSV file if they wanted it. To be honest with you, it's a very, very, very painful exercise of getting them to agree that Git commits was good enough. But for us, it was an exercise that we were willing to go through, because what we weren't willing to do is have someone trawl Git commits to create a spreadsheet to give them, because that's just a painful exercise in itself. And that's not self-service in any way whatsoever. And our mantra was always self-service for anyone that interacts with the platform. And an auditor is a customer of the platform. It needs to know what's going on and when it went on.
But it's still, I mean, I can imagine it's still a painful exercise to go through this. But great to hear it's possible. I think that's very motivating. Another question we got from Adrian is: what is the reason for multiple tags of the Docker image in this process? Isn't that the same image from the start? Do you need to do that to have a prefix to trigger deployment change? Like in Flux or something? Yeah,
so for us, it was a way of being able to easily differentiate where the container was on its life cycle to production, and having that prefix. Yes, it is the same image, but retagging is our definition of our ability and want for it to go to the next environment. So you move it. Exactly. And then because we had this pattern, being able to create new environments became very easy, right? We just retagged essentially, or we could have an environment that pointed at production and it would pull down the production tags. With a tag of 1.2.3, you have no idea where that's running. Yeah. If I have a tag of dev-char, I've got a pretty good idea of where it's running. It's definitely running in dev, and it may be running somewhere else. Yeah, understood. Cool. And then we got one other question here, which I expected. So first of all, amazing talk, very inspiring. How much time and resources are required to build such a platform according to your experience? And that's probably, I might guess your answer, which is it depends, but go ahead. No, I won't go with the complete consultant answer that it depends. If this wasn't a talk, I'd probably go with that answer. However, how long does it take? If you've got a pattern that works, which like I've kind of shown this in this talk, and I have a lot of the kind of boilerplate repositories that are required to be able to get this thing off the ground. It doesn't take as long as you think. If you've got the right, like the fact that we're using Kubernetes as the abstraction layer gets us already out the gate much, much faster than if we were doing this any other way. So it's really about flipping the question the other way around of how involved and wanting our product teams to work in a different paradigm and a different pattern. If that question is immediately, the ability to be able to build something like this becomes a lot shorter. If there is a resistance, it's obviously going to take a lot longer. The hardest part is to get the first product team to go. Once the first product team's gone, and they do a show and tell, and all of the other product teams joins, and they tell you that they've done 15 commits to production this sprint, and everyone's doing like 1 or 2 per sprint. The light bulb goes off on other people's heads that actually maybe this is the right way of doing things. It's how difficult it is and how long it takes to get the first product team to get on board. It is really the answer to your question. In terms of the platform and building those pieces of the puzzle out, the fastest I've done it is 2 months, with 7 product teams. That's not onboarding all 7 product teams, by the way. That's onboarding the first product team and building everything out. And then it was drip feeding the rest over the course of the next quarter. And then it was after the great thing about it is after you've got the product teams onboarded, the platform engineer's time is spent in the right area, which is how do I make the platform better? How do I give more features to the developers? So like distributed tracing, the service mesh kind of buzzword starts to float around a little bit about wanting one of them. And they're the things that platform engineers should be focusing on. They shouldn't be focusing on how do I deploy my microservice for product team Y. I don't know if that answers your question necessarily, but again, it's all about the first product team, however long the first product team takes, and also about the transparent communication of what you're doing. Mm-hmm. That's extremely important as well. So your first product team become your platform ambassadors. Yes. Right? They have to go out and talk about how awesome this thing is and how easy it is. And if they hate it, you're damn sure that every other product team is going to hate it, even though they've never used it, because they're just going to bitch about the whole thing all the time to all of their peers. So they have to become the ambassadors and the shining light.
So yeah, I like that. I like you to turn this into a first mover problem, and then with the things you said earlier, to make sure that you really convince and know what this first product team needs to become your ambassador. I think that's a great ending, I think, of this presentation. Steve, thanks a lot. That was great to listen to this step by step. I think it gave a very good understanding of how a platform like that could work. As I said in the beginning, we'll share the recording tomorrow. I hope I can also share the slides and the tips how to get started. If people have questions, and I'm sure that that's the case, I'll share the link to your homepage so that they can get in touch with you. I know you're providing both trainings and consultant work, so I think you're ready to help if it comes to more specific questions. Yeah, definitely. Feel free to reach out, drop me an email, follow me on Twitter, and send me a direct message, or reach out to me on LinkedIn, whatever you want. I've got a pattern here that works, and what I don't want to do is every company and client spend the same, have the same problems. Let's just focus on the areas that make you a business, right, and make you a differentiator. And we shouldn't all be solving the same problems over and over again. Absolutely. Thank you so much. Thanks, everybody, for joining. Thanks, everyone. Bye. Cheers. Bye.